Welcome to the Roboticist Chronicles, an ARC Specialties podcast, where we get into the nuts and bolts of robots, automation, and the implications of an evolving machine workforce.
Hello, this is Dan Allford with ARC Specialties. You're listening to the Roboticist Chronicles. We're up in Chicago at FABTECH. This is the American Welding Society's annual convention, and I'm up here with another Texas company. Max, tell us what you do for a living.
PushCorp is based out of Dallas, Texas. We are a manufacturer of spindles and compliance devices for robotic automation, specifically focusing on material removal.
So the way the robot industry works, you got the robot manufacturers, you got integrators like ARC Specialties, and we got you tooling guys. And we lean heavily on your company because we need the spindles, we need the tools. We've done a bunch of jobs together in the past, and we've got a couple going on right now. So it's been a great relationship.
Yeah, that's right. That relationship's gone a long time, and I think it's really important, the fact that PushCorp doesn't do any integration. We got to rely on you guys. Yeah, we got to rely on you guys to get the equipment out there.
But what you're doing right is you got a laboratory up in Dallas, don't you?
That's right.
Yeah, and so we're the same way in Houston. We believe that if you're going to sell a job, it's best to do the test. And frequently when we're doing tests, we figure out that we didn't know everything.
Right.
And we change the approach, we change the tool, something like that. That's what's going on right now with you and I. We're doing something where we're trimming elastomers, right?
That's right. Yeah, so in Dallas, we've got one of every tool we make, right? So if we start going down a path that doesn't work, we can easily pull an audible, pull another piece of equipment in, different, bigger spindle, smaller spindle, maybe a higher speed spindle, add compliance, active, passive, whatever needs to happen there, or we can even go to a belt sander. So being able to do these things in the labs allows us to do a lot of work in a short amount of time, which gets you moving faster to getting that PO and integrating the equipment.
Well, and elastomers, you'd think they'd be easier because they're soft, but
yeah,
that is not the case.
Truth.
Yeah, opposite of the truth. I'd rather cut a hard metal, I think.
Yeah, I'd rather grind welds all day long.
Yeah, which is something we've done also. And then let's see, the last one we just did was fiberglass.
That's right, routing fiberglass.
So we had a robot, 2 stations, rotary tables, your tooling, but the hard part on this one was they wanted to do all sorts of different shapes and sizes, so it was your tool changer.
That's right.
It really made it work.
That's right, yeah. If you need to go from a 1/2 inch cutter to 3/4 inch cutter, having that tool changer, be able to swap on the fly, that's critical for the success of a project like that.
So we're sort of encroaching on machine tools territory now.
A little bit.
Yeah, so we're machining and changing tools. Let's see, well, we've done, did another one back, let's see, you got a weld grinder, right?
Yep, yeah, we had the weld shaver. We're able to remove high volumes of welds, either robotically or like on a fixed boom welder as well. So if somebody's doing like a submerged arc weld, we can flip that submerged arc out of the way and come back with the weld shaver, remove large volumes.
And you're not using fiber, you're not using sandpaper at that point.
We're not. That's a cutter.
Carbide cutters.
That's correct. That's correct.
One of our big successes was up in Canada. You know, they do the oil sands, and they're making these parts, and it was all turned on the lathe, with one exception. They wanted to cut one small slot about that long, and they had to hold plus or minus 0.003 tolerance on it. And so the plan was they would take it out of the lathe, move it over to a mill, make one slot, shut it down, and our cooperation now, the robot sits there waiting, and as soon as the lathe stops, it cuts that groove.
Yeah, that's right. So think about all the material handling time that they're saving.
Oh yeah, it's huge.
And the chance of damaging that part while you're moving it, reinstalling it, bringing it back. Now that robot's able to do that process with the tolerance that they need. I mean, can't get any better.
And it was simple. Robot's underutilized, but it was still a great project.
Yeah, it's still better than somebody trying to do it by hand.
And so one of the other things you're doing, you haven't mentioned yet, is compliance. Because when you're starting to do finishing, you know, when you're machining, you want your tool to go to a specific point. But if you're going to do some kind of a finishing,
right,
you have to have compliance because the parts aren't right, the abrasive wears. What's your approach?
Yeah, absolutely. So the compliance allows the robot to apply a constant force onto the part. So if you think about it, the way we traditionally program a robot, you move it a millimeter here, a millimeter there, but a millimeter into a part, depending on what's on the business end that's contacting the part, a millimeter in could be 2 pounds of force, it could be 30 pounds of force. You really don't know.
Could be a crash.
Right? Yeah, it could be a crash, right? So the compliance device, having that compliance stroke in there because the carriage moves, hence the compliance portion. But then we also have a suite of sensors inside our active unit that allows you to apply consistent force. What that's going to do is it's going to give you better material life, better wear on the abrasive, make robot programming simpler, actually, because you don't have to be exact on that. But it's going to give you a level of control that emulates what a person would do by hand.
Exactly. When you're sanding or polishing, it's a constant force that you're applying to the part.
That's right. And that's what I tell everybody. It's really easy to teach the science. It's very hard to teach the art, right? So our device helps make that art a little bit simpler because we can fine-tune that process that would take forever to try to do on a robot.
Well, we're up here in Chicago, and I just wanted to highlight the stuff you're doing because it's the relationship between you tool builders, us robot integrators, and the end users that makes this whole thing work.
That's right. Yeah, we couldn't do it without you guys. We need strong integrators, and ARC Specialties is one of the strongest, so we value this relationship a lot.
What else do you want to talk about today? I cover it all.
Yeah, so like I said, we're based out of Dallas, Texas. We got the labs. If anybody's got anything that they want to come up and run through us or work together, be happy to process that through.
Well, thanks for coming on the show, and thanks for all your help.
All right, appreciate it, Dan.
Get you back soon.
Yeah.
I'll mark those for you. We're back at the FANUC booth. I want to talk to Mike Sharpe here because we're doing a couple things new at ARC Specialties. We're going to start doing some laser welding and laser cutting, and we're going to be working with FANUC for a reason. Explain what the advantage of FANUC robots when you get to lasers is.
So laser applications require precision and control. Laser is an energy source, and the energy source can be focused to a point. Whether you're cutting or welding, you want to have that precision, you want to have that control. The controller is related to the process parameters as I come in and out of a corner to give me a constant heat input, constant deposition rate if you're welding, whatever the application is. It's important to have that control tied to the motion. Secondly, the accuracy of the robot. We have new robots such as the M800, which are very accurate.
You're actually publishing an accuracy now, aren't you?
We are, plus or minus 0.1, and it's actually a bit better than that. So.
And so back in the old days, robots you only quoted repeatability.
That's correct.
I'm glad to see you're quoting accuracy.
Yep, that's correct. So that accuracy of that robot allows you to set what you get. You know, you can accurately deposit material, accurately cut, and you can even use it for offline applications, offline programming, download and run.
So 0.1, that's millimeters. So
yep.
So 4,000ths.
Yep, 4,000ths.
And you can do better than that.
I've actually shown to be much better.
We're using your laser robots right now for plasma, and we're holding better than that.
Yep,
so
much better.
All right. So you've got a whole range of laser bots, right?
Yeah, the 20IB is probably the most popular. That's the fully enclosed robot. We developed that right from the beginning for hot stamp cutting, because hot stamp materials, which are hot pressed, they're highly martensitic, very, very aggressive, abrasive splatter, so to speak, that comes off the cut. That robot is fully protected for that. It's got covers, and that allows us to enter more of the automotive space. However, that robot is also very nimble and quick. Anything that's related to, or not related, but any application that has a welding head, 20 kilos or less, it's mostly cutting, maybe beam on plate. It's very well suited for that.
And what are we looking at here?
So this is the M800 robot that we just talked about. The M800 robot is carrying the brand new scanner, the FANUC LS3 DIA. This scanner is a FANUC Galvo optically controlled scanner, so it has an X, Y, and Z path control. We're showing a guided beam with a visible light just to represent what the capabilities are of this product. This product would be ideally suited for applications maybe to replace spot welding, thin metal joining, maybe additive applications with a powder bed. Any of those types of things could be done with this kind of a head.
By scanner, you're talking about a welding machine.
It is a high-powered scanner, correct. That fiber, if we had a laser source at the show, would be delivered to the end, Inside of there, we reflect and modulate that to position that beam very quickly and very precisely. Part of that modulation allows us to do zigzags and C-clips and different types of patterns. We can even write the FANUC logo or anything. You want to put ARC specialties, we can write it out so you can use it as a part marker also.
So back in the old days, we had a very fixed focal length. So you're able to change the focal length on the fly.
Correct. I don't remember the exact parameters, but it's about 300 square by about 150 deep, maybe 300, I forget. But you can adjust that Z height. So the robot doesn't need to move in and out. You can actually do multiple steps, all with the programmability of this product. It's very fast.
A lot of things you can do with laser you can't do any other way. I'm looking forward to working with you.
Yeah, absolutely. Thanks,
for your
Dan.
time. Thanks for coming on with us.
Thank you.
It's Dan. I'm back with the ATI booth. We work with these guys on a lot of different projects. I got Tom McElligott with us. His specialty is his tool changers, and I want to talk to Tom today because this is the enabling technology that allowed ARC Specialties to win FANUC System Integrator of the Year award on our offshore robots. Because the two tools that were necessary on the offshore robots were very different, and the robot had to switch automatically in between them. Can you explain the point of this and how they work?
Yeah, sure. So what this is demonstrating is how our tool changers can help somebody use a robot more fully. So now you can have one robot arm and have multiple end effectors or tools, and that can be enabled by ATI's automatic tool changers. So in this case, we've got this FANUC arm. It's about to pick up a dispensing head, and it's going to go ahead and mimic applying adhesive to a pillar of an automotive body part. And then after it does that, it's going to drop off that dispensing head, and utilizing ATI's automatic tool change capability, it's going to pick up this flow drill screw head and do that operation. So again, ATI enables someone to take one robot and make it more productive.
But you're doing more than just picking up the tool. You can see by all these connections. We're connecting hydraulics, electronics on ours. I think we really challenged you guys. We were
Great point.
Yeah.
Great point, Dan. Yeah. So it's not just the mechanical coupling and uncoupling and the picking up of the tool, but it's passing all the utilities, whether it be power, air, fluid, signal, whatever it might be, from the robot side to the tool side, and allowing that end effector to do its job.
And we had three different communication protocols. We had a camera signal, we had hydraulics, and everything we threw at you guys. And none of these things are off the shelf, right? You configure them according to what we need.
Correct. So we have a lot of building blocks, right? So, and over the 30 years we've been in business, we've done this so long and come across so many different applications that the odds are if you need something to pass through someone else has before, we've got that module building block, we call it, and we just add it to the tool changer and make it that much more capable.
And I don't know if they're supposed to be, but we happen to have proof that these things are rated for seawater contact because we're splashing seawater on these, the robot's splashing it out, and they're running very well.
They're very durable. Seawater, salt water is a harsh environment,
yes,
but so is the welding and other harsh environments we're used in all the time. So they're very robust.
Well, as I said, I think it was the key enabling technology that allowed us to put robots on drill ships for the first time.
Well, we're happy to be that kind of linchpin between you and the end customer and the robot manufacturer and enable your win.
Thanks for all your help.
Yep, thank you, Dan.
Thanks for coming on today.
Sure thing.
Dan Allford, I'm back again. We're at the KUKA booth. Been working with this guy for 5 years.
Yeah, easily.
All on welding systems.
Yep.
So you're the KUKA welding guru.
Yeah, so now my new role is business development with the welding group. We cover anything welding, joining, additives, subtractive, tier ones to weird projects that you guys do, and really anything in between.
Charlie Adams, our contact at KUKA when we have these projects. So this isn't even a welding project, but it is cool, so I thought we would showcase it. What are we looking at?
Yeah, so generally we got two FABTECH KUKA robots. They're taking, one robot is the die and the other robot is the other side, and they're pushing. At the beginning of the day we started with a flat sheet of aluminum, and now we have crazy large projects.
So it's die-less sheet metal forming.
Yeah, and they're using it for rapid prototyping, aerospace operations, and really anything that you could think of.
So it takes very accurate coordination of the two robots.
Yeah, so they're doing a lot of math on the Makina side, and they're doing all of this and coming up with the path planning on their side.
One of the most unique things I've seen here.
Yeah, it's the largest robots at the show, and I think the coolest application.
So are we limited to 90 thousandths aluminum?
No. What they told me is they're doing some titanium, some Inconels. I heard 1/4-inch steel. Pretty impressive. They go to the larger robots, our Titan series.
So it's interesting new technology I just wanted to showcase.
Yeah, perfect.
And I wanted to thank you for all the help.
Hey, thanks
for coming on today.
Yeah, perfect.
Hello, it's Dan. I'm back. We're in the Gudel booth. I'm with Bob Rochelle. We've been working with Gudel for a long time.
Very long time. You're one of our longest customers. You know that. One of our oldest ones. Excellent relationship.
So what I come to you for is travel units, because robots only got a certain amount of envelope, and a lot of times if you need a long envelope, you put it on a travel unit, and that becomes the 7th axis, and the robot has 40, 50, 100 foot of travel at that point.
Exactly. Infinite amount of travel if you want to. That's kind of how it works, and that's one of the things we do. We expand the reach of the robot. So if you can't reach it all, we'll move the robot. Now you can reach it all. Mm-hmm. Absolutely.
The thing I like about your stuff, it's precise, it's linear, and available, because you guys keep a lot of this in inventory, right?
We stock components to build them, so we get hopefully quick deliveries. I've had integrators tell me that they buy our product because that part of the project, we take the risk out of it for them. They know what's going to come in, like you say, finished, done, put on the floor, and it works.
I don't know how to break this to you, but we build travel units too.
I know that.
But I'm
well aware of that, sir.
I'm glad you don't do robots, but that's not to say we don't use yours. When ours fits, we use it. When yours fits, we use it. I'm putting together one right now.
And that's the perfect relationship. I love it.
Yeah.
That's how we work together.
That's how robot integrators work. I got to go buy a robot from one of the robot companies, but then I need ancillary equipment, and the travel unit is a big part of it.
And whatever reason, we'll be happy to service you when you need us.
And so, what do we got going on behind us here? It looks like you're building whole gantries now.
That's an entire gantry system. That's correct. That's actually a unit that stacks the laminations and transformers. Extremely accurate placement, making sure everything is absolutely perfect, so when electricity flows, you get a transformer.
Who's welding the laminations together? Because we build those machines.
I don't know who's welding them, but we're stacking them, sir. All I'm doing is stacking.
Well, hook me up. So could we hang a robot on one of your gantries?
Absolutely.
So instead of one axis, we could have 3.
You could have 3, 4. We've done 10s and 15s. Yes.
I need to look for one of those jobs.
You should. That's a big job. You can handle that one, without a doubt.
Thanks for all the help.
My pleasure, sir.
Thanks
we'll
for coming
see you
on
in
today.
Texas.
Soon. Come on.
Come on.
Hi, Dan. I'm back. We're at the ABB booth. I've been working with ABB. You were the first robot we started integrating, man, I don't even remember how long ago. I got Doug Hixon. He's going to tell us about some of the latest stuff he's got going on with this robot here. Back in the old days, robots were only specified with repeatability, right?
Right.
Nobody talked about accuracy.
No, not at all.
Are you ready to guarantee an accuracy here?
Yeah, I can guarantee an accuracy on this robot. It's 300 microns max error, 150 microns mean error.
Microns. I've never even seen one.
Well, let's put this in English units. So 250 microns is 10 thou. So we have an average of under 10 thousandths of an inch anywhere in the robot's envelope.
Not bad.
Yeah.
And how do you do that?
How do we do it? So what we do is we take the robot in the factory. When we produce a robot, we put it in a laser calibration station. We put it under maximum load. In this case, this was a 12 kilogram arm, so we put 12 kilograms on it. And then we put it through 100 different points and laser measured it. From there, we put it through our algorithm, determined how much was related to mechanical tolerancing, deflection of the links, and compliance of the joints. We're able to reduce the error of a robot about that size of 5 to 6 millimeters down to 250 microns, or 150 microns actually on that arm. Yep.
That's pretty cool. So, way back in the day, I used to lead screw compensation, to compensate for errors in a lead screw.
Okay.
So this, in effect, is sit with 6 degrees of freedom compensation for all of this.
Exactly.
Including gravity.
Including gravity. That's the key. It's 60% of the error we see is relative to gravity, is relative to the tool itself. Only about 40% or so is mechanical stack-up tolerance.
But this is a collaborative robot, right?
That's correct, yep.
So you've got a precise collaborative robot.
Precise and accurate. So precise meaning the repeatability can go to the same spot every single time, but then the accuracy portion of it, we can go to the exact position we commanded it relative to the robot's base.
You know, if you rewind way back to when I picked ABB as my first robot, one of the things that I liked was the way you calculate and set up TCP, tool center point.
Right.
You know, but way back in the beginning, it would take me half a day and a calculator.
Right,
Okay?
right.
And that little device right there is what impressed me years ago. Why don't you tell us what it is?
Okay, so that is the ABB Bullseye. I believe that came to market back in the mid-90s, if I'm not mistaken, so it's been a long time.
It looked a little different. It was orange. It looked like a horseshoe.
That's right, and we can get these devices a little bit more ready-made. The old ones, you had to line up the sensors, or at least we did in manufacturing, so an improvement there, more of an off-the-shelf item. It is a single laser beam, and what we do is we teach a conventional 5-point TCP with it. So we measure one side of the beam, measure the other side of the beam, take half. We do that in 4 different orientations and then one for the Z direction. It's different than everybody else's. Often you'll see them do it faster because they'll have like multiple lasers. They stick the torch down there and then it's done. But that's just an offset. In order to do a true TCP, you need to orient the tool in multiple directions. In other words, generating a sphere around your fixed pointer. And that's what we do with the Bullseye. So you can stand on it, move it, whatever you want, it will still get you the same result. If you take a normal or off-the-shelf device, it'll dip into there, but it will only give you the offset based on the relationship of that device to the robot, in most cases. So definitely do your research.
Still working.
Yeah,
Right.
so if you'd like to see it in action, we can force an error.
Yeah, break it.
We're going to break it.
Do what my customers do to me.
So what's the biggest issue here, right? So
You're gonna crash
somebody
the
runs,
torch.
we crash the torch. So we can crash the torch a little bit. If we crash it too much, then it becomes out of the reach, or you run into singularities or other things. So I'm going to take this torch and I'm going to move it. Oh boy, quite a
that
bit.
was a bad crash.
There we go, super bad crash, right? Okay. I'm going to hit play. The robot first is in this demonstration is going to run back through these 100 points, a little bit of it, just to kind of show you above the area, to show you what you have done, where that crash is. If we went into this, we would obviously crash. I'm going to step out of the light screen, and you can see just the tilt of the torch.
See, it would have hit every one of these.
And we're not going to go through full 100 points, just a couple of small little paths. And we'll go through the maze too, just to show you. And then, of course, those that say, well, I don't program mazes for a living, we're going to do it on the arc plate as well.
And so I've had so many customers, they'll bend a torch, and then rather than correct it, then they'll write their next program with a bent torch, and so now they have no solution at all. So,
That's right.
You know, you've got 2 different programs that require 2 different TCPs. That's not going to work. So that's why I think this technology is so valuable.
Yeah, and what they'll do is then at the end say, oh shoot, we should have done our TCP, and then they go back to do that, and it's too late. Now they have no programs that work.
Right.
So.
Oh, been there, done that. You got to figure out which one you want to save. Because you only get one.
That is correct.
So what's the next step?
Okay, so the next step is we prove that it's off. It's going to go over to the Bullseye. And we've improved the speed of the Bullseye too. So that's always been a complaint, is it would first do a quick check, then that would take about 5 seconds. And if it didn't pass, that's where the several minutes would take. With this collaborative robot, we can do it just over a minute. So if we have any other questions, it's a good time to go over, but it's going to go through 5 different orientations, and then it's going to figure out where that wire is. And then afterwards go back into the maze.
So it's that easy?
That easy.
Okay.
That easy.
Well, you keep building the cool stuff. I'll keep implementing it. And in the meantime, thanks for your help. Thanks for coming on today.
Oh, appreciate it. Thank you.
Hi, it's Dan. I'm back. We're in the Miller booth. We've been working with Miller Electric for a long time. I'm talking with Sam Noland about their new power supply. We were using the Miller RMD. We can set up a very viscous puddle and bridge a long gap.
Yes.
And so we've got the robot that'll measure the gap. If it's wide, it oscillates and goes slow, and if it's tight, it stringers and goes fast. And that's all thanks to your power supply.
Well, we've worked really hard on the RMD, and I've used it a lot in robotics for the same thing, that it's very adaptable, it's easy to set, easy to tune for people, so it's good for understanding what your arc's going to actually do. You guys have done awesome on using it on pipe, which is really one of the most challenging things to automate, because there's so much to think of with the land, the gaps, the grooves, the bevels, all of that makes such a difference. So being able to have something that adapts easily, and we provide that information and feedback through the power supply for you to be able to take and be able to make adaptations on your own.
Yeah, we've got 3 guys on staff that were all 60-yard pipe welders, me and 2 others, and we taught it everything we know.
Oh yeah.
But the cool thing about your power supplies is for the hot fill and cap, we're running pulse spray.
Oh yes. The ability to be able to transfer on the fly, to transfer in the live arc, and to be able to transfer just quickly between passes makes it so that we can go from root to cap without any interference, without any changes. The operator just sets it and goes. And we know it's going to do it every time.
So I like the power supply the way it is. So why did you build a new one?
So what we found is that the Continuum is awesome. It's powerful. It's got a lot of waveforms. Most cobot people are just doing standard stuff. They don't need all that.
So this is focused on cobot?
This is focused on cobot and basic fixed automation. So steel, stainless, aluminum, pulse on, pulse off.
Well, our AI pipe welder is a cobot.
Yes.
So.
Y'all are advanced cobotics though.
Yeah. All right, so ultimately, it's designed for cobots. Anything else?
So it can do cobots. We can put it on gantry systems. Anything that uses Ethernet IP or Modbus.
Thank you very much for using a standard protocol, by the way.
I love Modbus. We're able to use that to open it up and be able to really get a lot of waveforms in. But then for anybody using Ethernet IP or standard, it's still there. We're not taking that away.
Yeah, I get tired of proprietary communication protocols.
Yes, I understand, and I'm tired of it too. The other side of that, we've also tried to make it more easy to just use. So things like communication lights on the front where I can see, yes, it's talking to the robot.
Is that?
Yes,
okay.
Yes, it's actually talking.
I see.
Same as my router at home. I know when I got a signal.
Okay.
We've moved all the connections to the front, so there's no digging around in the back to try to hook up your Ethernet cable anymore. All of that's up here where you can get to it quick and easy. But you'll notice it's headless because we're really giving you guys the power. Everything is accessible to you in here, and you can put as much or as little as you want onto your system to be able to use.
That's what we want. We want a big amplifier that turns small waveforms into big waveforms.
That's what we want to do. And we want to do it without showing up in anybody's thing. We want it to be like the water hose. You turn it on, you get an arc. And that's what we want at the end of the day.
Well, we're running Miller on TIG units. We're running Miller on these. I've even run some Miller sub-arc, so I appreciate all the cooperation. You need to come to Houston and see our lab.
I'm coming down there in October, so we'll have to meet up.
Thank you for your time.
Awesome. Thank you very much.
Thanks for being on today, too.
Oh, yeah, not a worry.